Okay, cool. Maybe only just like a couple more after that. So this talk is for you if you fall into any one of those categories. I'll go into building a startup out of a side project, running Neo4j at scale, and also all of the different quirks along the way, and then also it's so all the twists and turns that happen with that. Just to let you know who is talking at you right now, I'm Alex. This is sort of my background. I've spent my entire career in information security. I started off working at the NSA. I worked then at Microsoft, Lyft, and then spun off and created my own company just last year. And there's all these different angles I'm going to get into in particular that I hope that you'll find interesting. Yes, Neo4j does scale. Yes, open source is very hard, but it's very, very fruitful and beautiful. And I'm very excited to share all of this with you today. Drop anything in the chat, by the way. I want to be able to keep this interactive, so don't be shy about that. Where I'm coming from with information security, so I'd like to introduce you to the problem domain for people who know Graph, know Neo4j, but don't necessarily know about information security. At Microsoft, John Lambert, he's credited with this very famous quote saying, "Defenders think in lists, attackers think in graphs. And as long as this is true, attackers will always win." And so my job at Microsoft was on what they call the red team. And on the red team, we emulate adversary behavior. We pretend to be the bad guy to find what are those low-hanging fruit so that we can get at very sensitive assets and then report on them to improve Microsoft security posture. And on that team, the most important tool in our arsenal was the graph, because we were able to see like where are those entry points to go in, what is the internet exposed really low hanging fruit, how do we exploit trust relationships to move around the cloud and get to an asset somehow during a really long campaign or short campaign in some cases to prove some business value. And where I was going, like, I became very passionate about this problem. I've been passionate about this problem for like forever. And I took these ideas and I wanted to go and explore them at Lyft also. So taking this mindset, I joined Lyft, and then we open sourced these ideas as a tool called Cartography. Cartography, this was back in 2019. Cartography is a Python tool, and it does a pretty simple thing where it will retrieve data from various providers such as AWS, GCP, Azure, Okta, GitHub, and then put them into a knowledge graph and put them into Neo4j. And there's some really cool applications here. So we took a lot of these ideas, applied them to multiple different providers, putting them into a knowledge graph. And so the whole goal being adversary emulation, creating these cloud attack graphs. So if we can think about, if we work our way backwards, say that there is a customer database that we want to target as we're pretending to be the adversary, we're pretending to be an attacker, we need to find out who can query from it. That role that can query from that customer database, let's work our way backwards. Who else has access? Who can become that role? Work our way backwards, continue on, and then, well, are there any paths to that exposed, sensitive database from the open internet? Because it's very valuable to be able to say that, anybody, well, theoretically an attacker would be able to hit this asset from the open internet, exploit a vulnerability, and then over time, hop, eventually to something very interesting. We got into a lot of really deep technical depth where we're able to model these permissions of AWS and other complicated systems. So you'll have the identity, which is who you are, and also modeling what you can do. So putting all those things together and then evaluating them using a graph model based on all of the nodes that are attached to a given identity, we can deduce that you are able to read from a given bucket. You are able to query from a given data store. This is a very hard problem to do. Effective accesses in the cloud for many different reasons. Link to that blog post where I go into it in depth is right over there. And so there are a couple of challenges. Like, as I said, we open sourced this at Lyft, And it started off as an experimental project. Other companies loved it. We created a community around it. And I will say it is so motivating to be able to build something and then find somebody that you've never met before in the world. They find it useful. They build it together with you. We got so many contributions, and then it's been a career highlight to be able to do this for me. And I think that so to show you a little bit more concretely about what this actually looks like, let's get into a little bit of a technical detail where the overall architecture is that typically you want to use Cartography, you grab Cartography from the open source repo, and then you run it as a regular sync job, whether it's hourly or daily. And there's a couple of architectural decisions here. We maintain only the current snapshot of the data. So that means that if there is a storage bucket that existed yesterday, and then that storage bucket today, we have just chosen to delete it, then in our graph, we make the decision that we are going to clean that up and then delete that. It's a very heavy batch job that happens what I would call online, in the sense that we're not putting things into a CSV file and then loading them like using the CSV importer. We are running this using Python's Neo4j driver. So maybe online is not the right word. That's the word I'm using to describe that here. So everything is basically staying in memory and making that happen, which has some interesting technical consequences that I will get into in just a little bit. And this is the story of, open sourcing the tool with this attack graph mindset. And then I thought, oh, this is the most important thing for the business that we should be working on. I had some learning to do at that time. So there were things with the business that we needed to pay attention to. So with the business specifically at Lyft in 2019, we had just IPO'd. It was a good time. No, it actually kind of wasn't. So yes, seeing theoretical attack paths is important, but there really are other pressing needs for the business. So specifically, we needed to think about, all right, there was all these expectations around the business. How can we as a security team enable more business for Lyft? How can we be a part of more than just that? There's oftentimes a tension in security teams. Just to give you a little bit more context for those who are not familiar, where the security team is often seen as the no committee. Like, we'll tell you not to do something. Well, when you're working at a scale up like Lyft, where you're trying to grow the business as much as possible, that is not an option, where everything has to move super, super fast. There are also technical reliability problems too. Cartography was made as a experimental project made for hackers, like attackers, like that were former red teamers. And if red teamers are working on something hacky, we have, I would say, a pretty high tolerance for something that is not super reliable. If something doesn't work, we'll just retry. It's like whatever. But like when you want to run it in production as a service for other people, there's actual other things to think about. They have very real expectations. Neo4j has some sharp edges that I will go into in detail and how we address those in just a little bit. And we found ourselves in a little bit of a negative loop where without business support, without the love and care of and attention, the platform wasn't reliable. And without reliability, we didn't earn that support. So it was this negative spiral of like, okay, well, how are we going to, I was really passionate about building Cartography, rolling around it. How do we get out of this negative loop? People who have worked with Neo4j for as long as we have, you will have seen problems like this. You will have seen stack traces like this. Service unavailable, broken pipe, entity not found. This one's haunted, I swear. I think just a couple of weeks ago, we made like headway on there. I'm going to share like how we did that in just a little bit, just to illustrate all this frustration. But there is a way out of this. There is light at the end of the tunnel. Other problems in terms of getting adoption, usability, when we were trying to socialize this at Lyft, Cypher is love it or hate it. Here at Nodes Conference, we love Cypher, but let's be real, like it does have a steep learning curve. People tend to, it's polarizing in that sense, but I love it. You know, you have I describe it to naysayers as you are drawing out your ASCII art, making your model. And so in this case, we're going from compute instance, drawing it all the way to the IP range that represents the open internet. God, how intuitive is that? But, you know, what the skeptics will say is, does this data need to be a graph? What does a graph actually let me do? Like, what is the value add here as opposed to letting it be a table? And I thought really long and hard about this. And we actually had our chance, and we found exactly what that was, finding that killer app for Lyft. And it sounds a little bit backwards, but sometimes that's the journey of like building a product. Like sometimes you go with problem to solution. In this case, we had a solution that was built for a different problem, thinking about where we're going to apply it to other things. That killer app at Lyft was vulnerability management. The goal was we wanted to do business with the federal government, and we needed to stand up a vulnerability management program. What that means is we needed a way of inventorying everything we had at the company and then saying what security vulnerabilities applied to all of those assets. And I go into this in a lot more detail at a different talk at B-Sides SF 2023, but I'll summarize it here that the graph approach was absolutely compelling. It was killer, like for container image lineage. So specifically at Lyft, we ran a microservices architecture that ran on Kubernetes. And for microservices, what you're doing is that you're building out these container images and then you're deploying them to Kubernetes. If I was to take one of these container images and scan them, what am I going to get? So I have the user service. I scan the user service and it tells me that it's got a whole bunch of vulnerabilities right there. CVEs, these vulnerability ID numbers, 1, 2, 3, 4, 5, 6. Now, you might think, okay, I've got these vulnerabilities. The next obvious step is, well, just go fix them, right? Well, how? You know, without knowing. So a little bit more context here. The user's service will have been built from multiple base image layers. It is a composition. So if you're familiar with Dockerfile, this is the equivalent of saying like a from particular image, and then it's made many different layers up. And this is done at larger tech companies in order to do separation of concerns. So now the problem here is, given CV 1, 2, 3, do I just go and tell the owner of the user service, hey, here's a big plate of vulns, go fix them? No, like that's absolutely not possible, because if this vuln, here's a key part, if this vuln was introduced at a higher layer at say Bionic Base or at S2I Python 3, there's absolutely nothing that the user service can do to get rid of that vuln. And we cannot solve that unless it is a graph shape, unless it's represented as a graph. And so what we're able to do, we attribute those things. So we take all those vulns and then do this determination of from which layer was that vulnerability introduced. And the other part that's super important here is the graph model also lets us encode in this context of what team owns each specific layer. So the user's image layer, like for this, will tell the identity team over here that they need to fix this specific problem, whereas the infra team needs to fix those specific problems. And we can even go a step further and say, hey, infra team, when you solve this problem, you will fix it for all of these other downstream teams below you. All of them are waiting for you they're depending on you. And so being able to give that context, this at the time, nobody was doing this. We had to build out this custom tooling. I think the industry, security industry as a whole has caught up by now. But at that time, this was our approach to doing that at Lyft. And context is everything. We built out this sort of conveyor belt machine where we found out what is running in production, derive this image lineage, find the vulnerabilities, where were they introduced, and then turn that into actionability by creating these tickets, assigning them to the correct teams so that they all knew exactly what to do, add in even more workflows and logic, basically saying that as soon as that vulnerability gets fixed, automatically close the ticket, reconcile it in that graph. This was a lot to do. There was a lot in this process, but we needed to do that. Absolutely needed to, because we were an extremely small team. Everything was moving super fast. We had to rely on automation. And the good news the good news is we ended up getting selected. We ended up getting an selected for this potential $800 million federal employee transportation contract. Fantastic. That is a business outcome, something that every security team really strives for. And I guess the other part of that story is that this was really hard because we had this very ambitious system that we were building out, and gosh, like it burned out a lot of people. And then I go into this in detail on that talk that I mentioned, but in order to make this sustainable, we had to find ways to build controls, engineering scaffolding to make this all make sense. And there are many ways that this system can fail. And one of those ways to make that to make that work for us was building our own object relational model in Neo4j. I really did not want to do this, but we ended up needing to do it. I'm going to show you how we did it, and perhaps you can apply these techniques to yourself, or you can bug me to try to open source these techniques as a general purpose framework. I don't know, we'll get to that later. But this is what it does. So cartography, what do? This is the standard, this is what queries looked like before, where anybody who's worked with Neo4j, you're going to know that a query will look like this. To add this to the graph, you're going to hand write this query and basically say neo4j session.run. There are a couple of different things here that I will bring your attention to. So neo4j session.run, this is an auto commit transaction. That means that, I actually don't know what that means, but what happens in practice is that it will not get retried in the event of a failure. And if you're running something like a vulnerability management platform where you're sending out a ticket to people and then the rest of the entire 3,000 people company relies on you for that insight, well, God, you better be correct and it better be retried. And then these jobs take hours sometimes. So you want that transaction to retry. And so auto commit transactions do not retry. Instead of doing this, you will want to use what they call a managed transaction, which in the latest version of the Neo4j driver, they call it execute_write. .consume. Consume is another quirk. I actually don't know the details of what happens here. I know that in practice, though, this means that there are all these various buffers that happen in the connection that gets brokered between the Neo4j driver and whatever host you're using to broker that network connection. Those buffers need to be cleared. You have to explicitly call consume to make that happen. Unwind. Okay, credit to Michael Hunger for this, for that really, really great blog post that I read all those years ago. But this is a very important thing where you want to batch up all of the data that you're writing to your graph. So without unwind, thanks, Michael. Yeah, no, but without unwind, what's going to happen is the merges that are going to happen, you're going to be doing that one by one. You're going to be doing n number of transactions to your graph when, gosh, it really could have just been 3 transactions. So, so that's going to make things significantly faster if you can batch them all up. So you put all of your JSON, put that into that clusters thing right there, and then boom, it's going to batch it up and then send it to Neo4j in that way. Another quirk, make sure that your variables are bound. We got bit because I overlooked this. If you don't have a label on there, then you trigger something that's called an all node scan, which will take n searches. So instead of searching for all EMR clusters, it's going to look for every single node in your graph, which is not what you want in most cases. All right. That was a handful, but that was a lot, that was a mouthful. So we took all of that and then abstracted it so that what you do is that you give it some data model objects you simply call load. And I'll show you what this looks like concretely, where we build out these data model objects. I define what properties I want on a node. I define what the node should look like, what label it should have. I define what relationships should be on that node, and then send it to a code generation thing. So effectively making a mini compiler, so to speak, where it generates this. Please steal my code. I'm going to share it on the screen a little bit, but this is the end result where you take all of this models, I guess you can kind of think about like casts or scaffolding. It will generate this for you, and it will create the unwind. It'll handle the transactions. It'll batch it up. It'll make sure that if you have a network connection in between the your client and the NLB. If there is an NLB, you can configure that to be a lower thing. All these like technical things, we figured that out over the years. There's a war story. So this slide summarizes all of those things. Do all these things. Use unwind, use match transactions, ensure indexes exist, use the explain to find inefficient Neo4j APIs such as all node scan. Take the screenshot right here, grab that line right there from my source code, bug me to make an open source or general purpose framework. Yeah, you can grab that code as an example. And not Neo4j specific, but I will say that consider augmenting your Neo4j setup with other data stores for other purposes. And what I will say here is that we had a snapshot in the graph. We have a snapshot in the graph. I think that because for time constraints, we were building our vuln management system, I ended up keeping status, like state, like is this issue active or not on the nodes themselves. In hindsight, it might have been better to offload that to a separate data store just for separation of concerns. Question in the chat is, did you look at ORMs like Neo model? I did. I looked at several ORMs that were existing over there. And there are many at the time. I'd say this was like 2022 timeframe. They either did not do unwind. They did not let me configure NLB timeouts. So like a idle connection time and other different things. And then they did not let me configure the batches. Various different reasons where I decided to, needed to kind of build our own thing right here. So what I will say though is that this is hard to refactor. We're still not done with it. This project's been around almost 7 years. There are many modules here. A lesson, I would say, wherever possible, start with an abstraction or ORM-like approach from the beginning. Neo4j has provided very good docs and guidance. The next step, I think, could be to have a more opinionated stance on like what those constraints could be to create those schemas, and like constraints are your friend. I'll go into a little bit about how this general theme about taking open source project to a production use case that was actually an urgent need for our business and needing to improve that software quality in open source. So I mentioned earlier that in Cartography, we had all of these different use cases. It was amazing, but you know, the North Star for every open source project is that if it passes tests, ship it. And the reason why you want this as an open source maintainer, you want to grow your project. You want to have as many eyes as possible on it. And then you also want it to be in a responsible way. So you create tests that are non-controversial, make it so that there's as less back and forth as possible. We create a data model, but if I'm being honest, you know, I suspect it turned people off to our platform because it was yet another abstraction that they had to learn. They had no Neo4j, they had to learn my opinion about what it should be. But, you know, pluses and minuses here, there be cognizant of those trade-offs. And then overall, I will say that if your project solves an important enough problem, people will learn what they need, even Cypher. You know, I'm being a little tongue-in-cheek there. I love Cypher. A lot of people may not. Another lesson here is like being okay learning about disappointing people. You really can't make everybody happy. And building in public, meeting others, I think that's been incredibly motivating. It's been the highlight of my entire career. Open source in general helps with recruiting. It's helped build my own personal professional network. And also, I'll get into now, like building the sort of muscles needed for startup life, doing things that don't scale, learning about other use cases, going out and learning from others. You know, I mentioned that we started off with the original use case of Cartography was attack graphs, finding an additional use case for it for a more what you would call a blue team use case, learning all those things and cultivating that community. These are all things that have been instrumental in building a startup. Eventually, I found that it felt like I was working two jobs. There were things where the Lyft needed one thing, Cartography needed to work on another thing. I really enjoyed working on both, but you know, if I'm being super honest, a very happy day for me was that right in the middle of that Venn diagram where I was working at that intersection. Most of the time, though, it really was like I was working two jobs, and eventually, I had always knew that I wanted to be an entrepreneur. And it was also a very motivating signal to talk to other people in the community and say that, oh, you know, we really like Cartography. We've tried it out. We've seen something really cool. And might be really neat to do all these other different ideas. And so last year, myself and my co-founder Kunal, we went ahead and did that. We got into Y Combinator, that startup accelerator. We just did that last year. We were in the winter 25 batch. And our goal is to do what we did at Lyft and at Microsoft as a business. We go into this whole emotional up and down journey at this. Our talk was what it's like being the only security startup in your YC batch at B-Sides NYC just about a month ago. Go check out that talk on YouTube when it comes back out again. And yeah, like anyway, lots of ups and downs. It's been an amazing journey. I'm thrilled to be able to share just a little bit of it with you guys. I only got a couple minutes left. I'd like to go into some directions for the future. We are playing around with GraphRag. There have been a lot of great talks at this conference about how to do this. We're trying out our own way. I'm looking forward to go trying out some of the other techniques also. Solving for this problem of, okay, well, not everybody loves Cypher. Can we do English language? And we've seen promising results where we have taught it our own schema. We've taught it cartography. We've taught it the nodes, node properties, the labels, and everything. And it's able to do pretty smart things where it can do, if I want to find all the running containers, here are the things that we have running. It knows what property to get it from. It knows that, oh, that it's got to be, like, this is the enumeration of those things. It is all in uppercase. That is smart. That is really cool. And we also be able to find the, what you call, relationships. Well, I'll say here with GraphRag in general, I'm not the expert. I'm not the person to talk to about this. Read this book, Neo4j's free book on how to do this. It is really cool. Gives you great ideas about what to include in that context window. Areas for improvement, at least for me and for what that I'm super interested in. This is slow. There are definitely lots of ways to play around with this. Categorical properties in the schema. Yes, being able to do, I think, thinking about like concept to node label mappings. And also there's probably some model ensemble approach where if you can have like separate queries that are tool calls and augment that with Cypher generation, put that together, that could be something very compelling. But I'll end my talk closing the story. Maybe we'll have time for questions with some takeaways for my story where there really is nothing that beats graphs for relations. Neo4j can run at scale. It does run at scale. We've had so many war stories about that. If you've built an internal tool and thought that it could be something more, the founder journey, it's really tough. It's emotional. I can relate. Reach out to me on Twitter. Reach out on LinkedIn. I'm happy to swap notes and swap stories. Teach me how to do RAG. Yeah, and with that, yeah, thank you so much for your time. It's been really great. Thank you for having me. Oh, when I say slow, I mean like execution slow in terms of like wanting the agent to come back and be really smart. I'm not an AI engineer. I need to learn from, I need to get better at context engineering. We have a couple of minutes left for questions. I would love to open the floor. Thank you so much.